All right, so these are some examples of the density application problems. So question number 1 says a city has a population of 6,688 people. The area of the city is approximately 7.267 square miles. How many people per square mile live in the city? So here, this is a question about population density. And so the equation or the formula for that is that population density equals population over area. And so to highlight what variables we're given here, we've got the population is 6,688, and we know that the area is 7.267 square miles. So I'm going to fill that in. Population density equals the population divided by the area. And now here we already have our unknown isolated, right? Population density is already by itself. So I'm just going to plug this into my calculator. So 6,688 divided by 7.267, and I get 920.32, and this is people per square mile. Mile squared. All right, so that's a population density. Question 2 is just regular density. So given a 10-foot length of a tree trunk with a radius 3 feet, what is the weight of the tree trunk section if it has a density of 45 pounds per feet cubed? All right, now here, the equation for density is mass divided by volume. So let's see what we're given. Given a 10-foot length of a tree trunk with radius 3 feet. So length and radius. A tree trunk, if you can picture a tree trunk in your head, has the shape of a cylinder. And I'm given here length and radius, but what I really actually want is volume. So remember, to find the volume of a cylinder, we use the formula pi r squared h. So step 1, we're going to have to find that volume. Okay, so I'll do step 1. Volume of a cylinder, pi r squared h. We know that the 10 feet is our h, and r is the 3 feet, the radius. So I'm going to plug this in. Volume equals pi times 3 squared times h, which is 10. And remember, in our calculators, we plug in just the numbers, so 3 squared times 10. And then I just put a pi with it, right? I just carry that pi down, so we get 90 pi. So that's our volume. Now, the next part, the problem goes on to say, what is the weight of the tree trunk section if it has a density of 45? So it's giving us density, which is right here. That's density. So when I plug into my equation, I'm going to plug in 45 for density. Mass is what we don't know. And volume is 90 pi. And now I'm going to solve this. So to get m by itself, I want to cancel out the 90 pi. Notice it's in the denominator. So to cancel it out, because it's being divided by 90 pi, I can do the opposite, which is to multiply by 90 pi. Now remember, whatever I do to one side, I have to do to the other. So I'm also going to come over here and multiply by 90 pi. All right, in my calculator, I'm going to plug in just 90 times 45. So we got 4,050, and I'm just going to bring the pi down. Equals 90 pi's cancel over there, and we get m. So we have found that the weight / mass is 4,050 pi and our weight was in pounds. And I was able to see that by looking at the units of the density itself. Let me clean that up. LBS. Okay, so now the last one. This is one of those BTU problems. So remember, for this equation, our formula is the BTU per 1 of whatever our units is, usually cubic feet, probably always cubic feet, equals the BTUs in your tank over the volume of the tank. All right, so a cylindrical, so a cylinder, we got a picture here, tank, has the dimensions shown. How many BTUs will the tank provide? So this is asking for BTUs in tank. That's this one right here. When filled with natural gas. And then it tells us that the 1 cubic foot yields 1027 BTUs. So that's this one right here because it's over the 1. So I'm given those. I know that the yellow is what we're looking for, right? It says how many, so this is what we want to find. That means that I should be able to find the volume of the tank because I need to plug it in. Well, to find the volume, I'm going to go to the picture. In this picture, we have the radius and the height of our cylinder. So the radius is 5, the height is 14. Remember, volume of a cylinder is pi r squared h. Plugging in, we get pi times 5 squared times 14. And I'm going to plug in my calculator, 5 squared times 14. And so I get 350 pi. That's my volume. So now I'm ready to plug in. So we have 1,027 BTUs over 1 equals the BTUs in the tank, which is what we don't know. I'm just going to put an X. You can write BTUs, it doesn't matter, over the volume, 350 pi. All right, now it's time to solve for our variable X here. Notice it is being divided by 350 pi. So to cancel that out, I'm going to multiply both sides by 350 pi. Those cancel. Remember, anything over 1 is just the number. So the fact that this 1 is here doesn't really matter that much because it's a 1. So, and if it helps you though, right, in your calculator, you can do 1027 divided by 1, get 1027. So now I'm going to do 1027, but anyway, times 350 equals 359,450, bring down the pi. And this is the BTUs in the tank.